probably don't have to tell you that self-driving cars and other autonomous systems require a precise visual understanding of our world in order to be useful. But do you ever wonder where geospatial data comes from? The vast majority is taken by satellites and from cameras attached to planes, but a new decentralized network is helping amateur drone pilots capture and contribute ultra-high-resolution data. I'm Jennifer Strong, and this is Shift.
Now here on the steering column is a device called Auto Cruise. You simply set the speed you want.
Self-driving robo-taxis are already on the road in 2 U.S. cities.
As the disc rotates, a mirror reflects the light in the way that depends on how the signal was recorded.
This is the 100 terabyte I present to you Electro, the Moto Man. Ladies and gentlemen.
I would say that one of my greatest skills is my ability to interact with humans.
This episode, we go fly a drone and learn how that data is helping power next-gen apps for things like disaster response. Harness the power of AI agents at scale, without vendor limitations. The agency, spelled AGNTCY, is the open-source collective building the Internet of Agents to enable seamless agent-to-agent collaboration. Explore use cases on agency.org now. That's agntcy.org.
From Zuckerman Spader. For 5 decades, Zuckerman Spader has been a leading litigation firm trusted by in-house and outside counsel, businesses, and individuals. With offices in Washington, Baltimore, New York, and Tampa, Zuckerman Spader serves clients throughout the country and around the world in high-stakes disputes, enforcement matters, investigations, and at trial. When the lawyer you choose matters most. Online at Zuckerman.com.
My name's Alec. I'm the Chief Operating Officer at Spexi, and I'm going to take you through how to fly a drone on the network.
Alec Wilson is helping Spexi build one of the world's largest drone imaging networks.
So first things first is you want a compatible drone and device.
We're at the startup's new headquarters in Vancouver, Canada.
So we work with the DJI Mini series, specifically the DJI Mini 2, Mini 3, and Mini 4 series currently, which is the vast majority of drones that exist in the world today. So you need one of those drones, and then you need an Android device. We don't currently work with iOS devices because of a limitation on the drone hardware side, but luckily there's lots of them out there. So first thing first is you power on the drone and the controller. And if you come with me over here. It's okay, you can walk over this. The next step is to power on the app and connect it to your controller. So at this point, the drone is gathering itself. It's trying to find some GPS satellites to make sure that it can locate itself, which is totally normal. And then we're going to open up our mobile app and get going. One of the really nice things about this network is you don't need to install anything. You don't need to do any hardware installations. The drone out of the box comes ready to fly, and all you need to do is download our mobile application, and then away you go. There's a few setup steps within the app itself, but they're very quick, and so that we make sure you can get paid when you fly and things like that. So then all we do is we look at a map of available hexes, and we click on one close to us, and then we go over and we click setup. And then it's going to open up the hexagon that you need to fly, and you can visually see where it is. And then from there, it's as simple as hitting the fly button. And we're going to step back a little bit. And then the drone takes off, and away we go. And so now the drone, as you can see, is going to fly up to its flight plan altitude of about 80 meters above ground. It's then going to follow terrain at that altitude to keep itself there for image quality. And as you can see, I'm not doing any of the flying. The software's doing all the flying. So we're going to look up, monitor the airspace for safety. We're looking around, monitoring the airspace for safety. We fly at a certain altitude such that it's very unlikely that there would be any incursion with manned aircraft flight patterns. They fly over 500 feet above ground. We keep the drones under 300 feet above ground at all times. I actually used to fly helicopters in this airspace all day long. This was my backyard, thousands of hours flying in the Vancouver area. And so I'm quite sensitive to the safety risk that drones can cause, and we've designed the system to be incredibly safe. And so now you can see the drone is actually centering itself over its pre-programmed station, and it's going to start taking a series of images. This happens throughout the hexagon in a completely standardized way. It takes about 7 minutes. And then you as the pilot go to the next hex, you change the batteries, next. And so you can do this all day, and then you get rewarded for each successful flight that you do.
Can you describe why a hex and things like that?
So this is actually, most drone pilots won't even fully understand this either. So we got to start from beginning. What we've developed here is a really novel system to capture imagery over large spaces. The reason we've used the hexagon system is because we can divide the Earth into equal parts using hexagons. And therefore, we can make the capture process the same everywhere. Everywhere on Earth, this is the same process that you would follow. That's really important because customers want the same imagery everywhere. And so if you make the input process the same, and you use the same methodologies and input sensors like we do with these drones, then you generate really, really good data across the entire Earth's surface. And so the flight plans are already set up for you. So simply all you have to do is get close to one of these hexes, open up the mobile application, and then make sure it's safe to fly. And there's really not much else to it. So as you can see, the drone is, well, we'll have to find it. Oh, there it is. You can see it just over there. It almost looks like a bird, but it's not flying like a bird. It's flying very straight. So it's just centered right there, just right above these cranes. If you look up, it's right in that cloud there. You see it? It's just a tiny little speck. Yeah.
Oh, now I see it.
Yeah.
Wow.
So that's it. It's just a little drone. Huh. And that's one of the reasons this also scales around the world, is because the drones are so small and so light. They introduce a very little amount of risk into the airspace, but also you can't hear them or you can't see them. And so for most folks around the world, they just don't realize that there's drones flying around, which is the same with satellites and planes. There's satellites circling the Earth 24/7 imaging us, but we're not worried about it because we don't see them or hear them. And it's the similar situation. So there it's moving to its next point now. Again, see, fully autonomously, I'm not doing anything. The software is controlling the flight. The imagery is privacy protected. The imagery is not high enough resolution to pick up faces or license plates or specific details, but it's good enough that it unlocks an entirely new use cases for customers, because it's much, much better than the next best imagery source. So this is kind of this new model that we've unlocked using software, using all of our experience flying helicopters, flying planes, and putting it all together into software and product so that we can then scale this product.
How do you deal with different restrictions in different airspace licensing, or do deal with different requirements for every city?
We do. Not city, but drone regulations are country specific for the most part. In the United States, state by state can get a little bit tricky. But another one of the magic pieces of this network is that the local pilots are doing the flying. And drones are not a new technology. They've been around for a while. There's existing regulations in place for pilots to follow. So simply they're required to make sure that they have the right things in place, whether that be a pilot's license or some insurance requirement or what have you, so that they can fly safely and legally in their hometown or their home country. In Canada, you don't actually need a license to fly these small drones because of their weight. In the US, you do. And in Europe, in some countries in Europe, you don't. In some countries, you do. And so it varies. But ultimately, drones are being flown in these countries all day, every day by lots of different people for different use cases. This is just another one of those use cases. So when you're done, simply all you have to do is let the drone finish, and then we can hit the return to home button, and you can hear it beeping at us, and that means that the drone is going to fly itself home. So again, not doing any flying. Worst case scenario, we could take manual control of this drone completely and bring it back down to whatever altitude I wanted, or fly it however I wanted as a manual flyer. But I've got it programmed based on my safety settings, which all pilots will have slightly different ones depending on their operating environment, to just come straight home at 100 meters and descend. So if you look straight up, you can see it's directly over top of us. And I know it's hard without the sunglasses, but then now it's just going to start descending down directly over top of us. And that's that.
Harness the power of AI agents at scale without vendor limitations. As an open-source collective, the agency, spelled AGNTCY, is building the Internet of Agents to enable seamless agent-to-agent collaboration. For business leaders, this means faster innovation and scalable solutions tailored to the multi-agent software your enterprise is creating. Visit agency.org to explore use cases now. That's agnTCY.org. You don't need me to tell you how hard it is to run a business in this climate of constant change and unpredictability. Thankfully, Constant Contact's award-winning marketing platform is here to make marketing easier and more effective for small businesses like ours. The best part, you don't need to know anything about marketing. With their all-in-one platform, you can create and manage attention-grabbing campaigns in just a few clicks. Email, text, social media, events, landing pages, you name it, it's all in one place. So no more juggling dozens of different tools. You also get automated sending, real-time reporting, and tools that actually help drive sales. So you're not just marketing your business, you're growing it. Pricing is transparent and based on the size of your list, so you're only paying for what you need. That's why over 500,000 small businesses trust Constant Contact to stay connected, top of mind, and ahead of the competition. Get a free 30-day trial when you go to ConstantContact.com. Try Constant Contact free for 30 days at ConstantContact.com. ConstantContact.com.
Hi, I'm Bill Lakeland. I'm the CEO at Spexi. So Spexi is a decentralized network of drone pilots collecting imagery at scale around the world. It's very automated, very simple, and it's basically collecting a new image layer of the planet at a higher resolution than what satellites and aircraft are collecting at, and at a higher frequency. And because we're collecting data like that, there's a whole bunch of new use cases that this unlocks, especially in the spatial AI, metaverse kind of systems and platforms. Unlocks these exciting new use cases because of the potential of the data and the fidelity of it. I come from a long line of flying aerial mapping over the last 20 years and have sort of reinvented the way that that's happening with the drone platform for decentralization of drone pilots and their hardware to collect imagery at scale globally to create a new image layer. So the company is founded in Vancouver, BC. We're here because that's where our team is. That's where, I've been aerial mapping based out of BC for over 20 years now. We've been flying all over North America for that period of time. A lot of what you've seen in Google Earth would have come from one of my airplanes over the years. So yeah, we started building the team here. Now we're growing across Canada and into the US as we scale. We're a recent Series A company, so that closed last December. And so we're scaling up, and so are our teams in different areas. And the pilot network is all over. So the pilots themselves are up to like 4,000 contributors across North America right now, with over double that on the wait list. And so that team is spreading very quickly. Yeah, so traditionally cities and governments would buy the data. They do that with aircraft and satellite data. They've been doing that for years. But because we're making higher resolution data and decentralizing the capture, there's, it's higher frequency and it's lower cost because of the decentralized nature, meaning we're using passionate pilots that just want to go out and fly. We give them a really simple and fun platform to fly and earn. And so it makes it very easy for us to collect data all over the world at a much lower cost. And so that opens up opportunity to new buyers, as well as the data being higher in quality, like the fidelity of it. You can see more. You can actually see the cracks in the sidewalks. You can see what type of roof shingles are on the roofs. You can see all these things that you couldn't see before. It opens up new use cases. And because AI and spatial computing is advancing at the pace that it's at, it needs really good data to be trained on. It needs the better quality the data is trained, the better quality the outputs that it provides, right? So it's sort of unlocking the use cases for us in so many different dimensions and so many different enterprises. For one, you need to understand the space. It's fairly niche. There's not a lot of companies that do it. Even back when I first got into this, there's one company in the province we're in that flew this type of imagery. And so really understanding that ecosystem, really understanding what good quality and consistent products are that companies can reliably build on top of that as a reliable data set to start verticalizing into whatever it is they're doing, whether that's insurance, whether that's utilities, whether that's city operations for smart cities, whether that's surveying companies or construction. It goes on and on. But they need a really consistent data layer. And so then it's like, okay, we're burning a lot of carbon because they're flying airplanes around. They can't scale. You can buy another plane, you can buy another sensor and go farther, but that's not really scale. How do you actually scale this kind of knowledge and get this in the hands of more people and make the world a more efficient place? And so that was a problem we set out to solve. And I think that sort of the technology changes over the past 5 years have really unlocked this. Drones are now they're miniaturized. So micro drones are what we use. So below 250 gram drones. So they're all over the world. We can access them everywhere. Social media is the way that we access the pilots because they're all there and they're available and they're passionate. They're like, hey, I have a drone now. What can I do? We give them some purpose and cash to be able to go out and fly. And it's very simple and fun. So That network is there. There's blockchain elements to this project as well. And because we're using decentralized hardware and pilots, we need to be able to make sure the data can't be tampered with. And so blockchain is actually a technology we can put into the system to actually authenticate that data and make sure the data is what it's supposed to be and can't be tampered with, as well as creating ownership economies down the road as decentralized networks can do if we choose to go that route. So our goal is essentially to create the most accurate data layer of the planet that's very referenced so that any system can put all their data on top of it to align it with the Earth. Because if you talk about using contractors in cities, like an airplane contractor in every city, you've got different data providers, you've got different alignment issues and things. The good data in, good data out problem starts to become a real problem when you're building large geospatial models, kind of like an LLM, but it's just like a geospatially charged model where computers, humans and computers can interact with the digital world to query it. And when you want to create a very consistent layer across the planet, you need a very reliable base layer of information to build on top of. And that's one of the main kind of go-to-markets that we have right now. We're in almost 200 cities now in North America, so it's scaling very, very quickly. We're starting to work in the UK and some stuff in Mexico. So we can do this here, we can do this anywhere. And the US is actually a harder country to actually do this in, believe it or not. And we've been able to do that as well, very well. So this is global. Competitors, it's interesting because there's no drone platforms that are doing what we're doing. There's pilot networks. So if you owned a windmill and you wanted an inspection of a windmill, you could contact a company. They would assign a pilot. They would do a flight of your windmill. You'll probably get data that maybe you're not totally happy with, or you have to sort of handhold through the process to really get what your company needs. We don't do that. We're literally an image layer. We're like a data layer of the planet, just like how Google Earth is, at just a much higher resolution. There's no other drone platforms that are doing that. The only other companies that do that are satellites that are imaging the Earth and airplanes that are imaging the Earth at a bit of a, less of a cadence than satellites. And so we're doing the same thing as what that is, right? And it's a very sort of generic layer of data that can be used for thousands upon thousands of applications that AI is really amplifying right now for us. Now we're seeing demand. We've got product market fit with the pilots. The demand side of this is starting to take off, and now it's sort of really coming down to scaling internationally. And from everything we've seen, there's no faster way to scale supply than actually having a decentralized pilot network, supplier network, or us being with pilots. So we are looking at adopting a token into the system. There's been a foundation recently launched called Layer Drone, which is the place where pilots will actually live. It'll be the landing spot for them, and that'll be where the protocol is, the set of rules and the technology stack for the automation of the collection and storage. And of course, Spexi will be the first adopter of the data coming through and tuning that data specifically for LGMs and AI spatial computing and smart city operations and all these different use cases that really need the data to streamline their operations and add value to the business.
This episode was produced by me and Emma Cillekens and mixed by Garret Lang, with original music from him and Jacob Gorski. Thanks for listening. I'm Jennifer Strong. AI agent collaboration isn't all that easy for enterprises. As an open-source collective, the agency, spelled AGNTCY, is building the Internet of Agents, a shared collaboration layer where AI agents can discover, communicate, and collaborate. To learn from AI innovators such as Cisco, Crew AI, LangChain, and MongoDB, visit agency.org and explore use cases now. That's agntcy.org.